Okay, this is example 61.3. Virginia and Campbell had 100 kilograms of a 20% glycol solution. How much of a 40% glycol solution should they add to get a solution that is 35% glycol? So, first equation is just about stuff. We start with 100 kilograms of stuff, so don't know how much. And then we're going to end up with some stuff. First equation. Now we're going to write the second equation, which looks just like this, except we're going to put in the percentages. So the 100 kilograms is 20% glycol. So for adding is 40% glycol. And we want to end up with 35% glycol. All right, so we have two equations, two unknowns, and we can solve this by substitution. But before I do that, I'm going to go ahead and multiply everything in the second equation. So just leaving this one the way it is. And then this one, 0.2 times 100 is going to be 20. And then 0.4x and then 0.35y. At this point, I would probably want to multiply that second equation by 100 to get rid of the decimals, but for this time, I won't do that, just to be different. So I'm going to use substitution, which means I'm going to plug this in for y in the second equation. So I'm going to have 20 plus 0.4x is equal to 0.35 times 100 plus x. And now I'm going to multiply that out. So 20 plus 0.4x is equal to 35 plus 0.35x. I'm going to subtract 0.35x on both sides, and I'm going to subtract 20 on both sides. So I'm going to have 0.05x is equal to 15. And then when I do that division, I'm going to have 300 kilograms. That's how much 20%, that's how much 40% glycol solution I should add to the original 100 kilograms. Okay, example 62.2, we're going to solve this quadratic equation. We're going to have to use completing the square. First of all, we need to get everything on one side in order from the highest power of x down to the lowest power of x, or down to the constant. So everything's on the left side to start with. I need to divide everything by 5 because the leading coefficient is not 1. So that's going to give me x squared minus 2/5 x plus blank equals negative 3/5 plus 0/5, which is just 0. And then I'm going to add the same thing to the right side that I add to the left side. We're going to take half the x coefficient and we're going to square it. When I do that, the 2's cancel and I'll have 1/5 squared, which is 1/25. So that's what I'm going to add to both sides. And now the left side can be written as a perfect square binomial. It's going to be x, and the minus sign tells me to put a minus. And then the number that goes here is going to be half the x coefficient. The x coefficient is 2/5, so this will be half of that, which is 1/5. On the right side, we have negative 3/5 plus 1/25. So we're going to multiply that first fraction by 5/5 so that we will have the same denominator. So we're going to have negative 15/25 plus 1/25. So x minus 1/5 quantity squared is equal to negative 14/25. Take the square root on both sides, and you will have x minus 1/5 on the left is equal to plus or minus the square root of negative 14 over the square root of 25, which is 5. And finally, we're going to add 1/5 to both sides and use Euler's notation for our answer. So x equals 1/5 plus or minus the square root of 14i over 55. Okay, example 63.2. We're going to add 30, 55 degrees, and 10, 170 degrees. So first thing I'm going to do is go ahead and graph that first vector. So we're going 55 degrees from 0 to 55 degrees, and we're going out 30. Now we're going to drop the altitude so that we can find the sides of that right triangle, which will be our x and y coordinates. We know we're in the first quadrant, so both our x and our y are going to be positive. So we're going to use 30 cosine 55 for x and 30 sine 55 for y. If we punch that into the calculator, we're going to get 17.21 for our x and 24.57 for y. All right, now we're going to graph the other one, 10, 170 degrees. So we're going to go around 170. That's just barely less than 180. And so we're going to go out 10. And that angle there is going to be 10 degrees. First of all, we know we're in the second quadrant. So x is going to be negative, but y will be positive. And we're going to do 10 cosine 10 degrees is x. 10 sine 10 degrees is y. We'll put those values in there once we punch that into the calculator. And now we're going to add those together. So add the x's, add the y's, and that is your result. Now we want to change that back to polar coordinates. So if I were to graph that, it would be in the first quadrant since x and y are both positive. My x is 7.36, my y is 26.31. So I just need to find that angle theta and the length of that hypotenuse, which is r. So first of all, to find theta, I'm going to say that the tangent of theta is opposite over adjacent, which is 26.31 over 7.36. I can't use tangent because I don't know theta. I'm going to use inverse tangent because I have the ratio, not the angle. So to punch that into your calculator, you would hit 26.31, then divide it by, then 7.36 equals, then you would hit second function tangent, and that would give you that theta is about 74.37 degrees. Now you need to find r by using the Pythagorean theorem. So 7.36 squared plus 26.31 squared is r squared. If you punch that into your calculator, you punch in 7.36, hit x squared, hit plus, hit 26.31, then hit x squared, then hit equals, and then to find r, you're going to have to hit the square root of x button, and that will give you that r is about 27.32. So your final answer is going to be 27.32, 74.37 degrees.